I told you I was going to start the next video with an updated illustration. Well, I guess technically I am doing that, but I want to make this one short and just show you an alternative way that we may consider uh, using. And actually, as I thought about it, I think it's preferred. It's not going to give us any different answers. It's not going to give us a different uh, uh, end result, but it's a little cleaner, and I think I like it a little bit better. So let's. I should have already had this done, but let's get our stuff. And I keep forgetting how this is. Party belief. Yeah. All right, guys. So we're starting clean here, and we'd like to run our analysis. So the first thing I want to do is create the contingency table, and I'm just going to keep it simple here. We're not going to have as much going on. We're not going to separate things out in terms of just males and just females like we did before. And I was illustrating this. We want to run the full analysis. So what I want to do here is run x tabs tilde, and I'd want to run belief plus party plus gender, and I want to run that for the entire data set. Now, if I run the contingency table again, what it does is it focuses on the last categorical variable that I put in. It examines the first two across the subsets of the last one. So, nothing more than we did before. Now, unlike what we did before, though, what I want to do next is I want to run the full model. And guys, this is our saturated model, so I want to run so Loglinear model. I want to run it of part or belief over party. And really, guys, I'm not doing anything different than I did before. If you want to skip ahead, you can do that if you like. But I've got to get... all right, cool. Oh, shoot. All right, remember. And just let's go ahead and get in mass 2. Now when we go up and run full model, things should be, what did I do? This is getting annoying. Oh, I misspelled contingency. That's lovely. I promise you I can spell, I just can't see. Okay, now we've got this. So you guys, if this was a classroom, you could remind me that I misspelled contingency. So guys, if I go a summary of our full model, what I'm most likely going to see here is a non-significant result, telling me that I need to go on to the next stage. Now, the next thing I'm going to do is I'm going to call this next model number 1. And what I'm going to do here is I'm going to do Loglinear model. And here I'm going to do my main effects. Plus my two-way interactions. And of course I need data to be equal to, this is going to be annoying, wow. Okay, so I'm going to do summary of my next model 1. And you'll see that we still get a non-significant result telling us that we need to go further. Now, again, that's something I did in the previous videos. I did an ANOVA over what I call this a full model and next model 1. And you can see that I get a non-significant result telling us we need to go on. So I examined the highest order first, the three-way interaction, and I looked at my next model, which included all of the main effects plus the all of the two-way interactions. So what I'd want to do next is I'd want to take out these two-way interactions one by one, and this is ultimately the reason I'm putting this video up. So I wanted to show you this how a little cleaner way to do this. What I'd like to do now is give you a more systematic method for removing each of the two-way interactions, because we're going to remove those one by one until we see a statistically significant result, in which case we'll go to the previous. Now in this case right here, if we get down to where all three two-ways or interactions removal are statistically significant, then we'll go back up and accept the full model. But you know, we'll just have to see what happens. Now, a really cool way to do this is to use what's called an update function. So what I want to do here is I want to give it first of all a new name. So I'm going to to get rid of the in the next model 1. The first thing I want to do is I want to get rid of the first interaction, which is belief and party. So I'm going to call this belief party, and I'm going to use the update function. I want to take my old model, which is next model 1. I want to go a space dot tilde dot, and then I want to go a minus the belief party interaction. Now let me make sure I had belief party. Okay, yeah, that's the way I had it, okay? The next thing I want to do, and I can go up here and get this, is my next interaction I ran into was I had belief party. The next one was belief gender. So guys, I'll call this one belief gender. And I still want to update this model, but I want to take out this interaction. I'm sure you know where we're headed next. The next interaction that we had was party gender. So I'm just going to call this party gender. And I want to eliminate that part. Now this makes our analysis a lot cleaner, because what we can do now is we can run our ANOVA across our next model 1 with belief party. Now let's think this through. What do we need to look for? Well, if we get a non-significant result, it means we need to go on. If we don't get a non-significant result, then we stop. So we go through this and we actually get a significant result. Guys, I want to go ahead just to illustrate. And if I take out the next one, which is belief gender, I get a non-significant result. So I need to examine all of the, what I call the last one, party gender. And I get a non-significant result here. So when I, again, collapse this down to where I'm taking out the two-way interactions, notice I get significant, significant. So what I need to do is focus on where I have non-significance. And guys, this is what happened when, let's see, this one right here was the ANOVA between belief and party. So this is where I took out the belief party interaction. So what does that tell us? That tells us that removing this effect created a statistically significant model. So guys, at the end of the day, this is all about the belief in the party, just as we saw before. Anytime you bring gender in, it creates a non-significant change, and gender just isn't incorporating much into our model. Now, I want you to look at this, the mosaic plot, and what did I call the contingency? Shoot, what did I call that? Contingency table. Well, I forgot. Shoot. It's kind of hard when you contingency. Okay. Okay. Table. This reminds me, I'm getting on a tangent here. Played in a golf tournament one time where this is back when I was a good golfer, and they had a rule that you couldn't improve your score from the first day over 10 shots, and it was a pretty stupid rule. It wasn't a bad rule if you're going from like flight 5 to flight 4, flight 4 to flight 3 or something like that. But if you're going from the first flight up to the championship flight, it was really a pretty silly rule. And so I remember I went out and shot 74 the first day, which was really a pretty high score for me at that time because I was a pretty good golfer. So the next day I went out, I couldn't shoot a 64. It didn't matter because I didn't shoot many 64s anyway. But this one particular day I played really, really well. And I had a putt on the last hole, about a 6-foot putt, to shoot 64. But if I shot 64, I'd be kicked out of the tournament because I shot 10 shots better the second day. So I'm standing over this this short putt, knowing I had to miss it and make the second one. So I have no idea where that came from, but that reminded me of this right up here where I'm having to misspell something intentionally. Okay, guys, contingency table is pretty cool here, because what this does for us is it tells us, what's the guy that talked about the rest of the story, Paul Harvey. It kind of tells us the rest of the story here. What you can see is when we examine choice over life, we can see that when we combine the genders, there's a discrepancy in the size of the boxes. So what you got to do, you got to imagine scrunching these together, putting these together, because we're taking gender out of it, right? Putting these together and you can see a difference. But every time we bring gender into it and compare choice across gender, life across gender, regardless of what party it is, even looking at this way, Republican, look across gender, there's not much difference in the size of the boxes. So when we bring gender into each one of these components of our frequencies, gender just makes no difference whatsoever. So guys, at the end of the day, that's why gender turns out to be something that we need to ignore here, and the relationship between belief in gender is really, belief in party is really not affected by gender. So guys, that's all, guys. It's just a better, cleaner, it's just a cleaner presentation of how to do what we did in the previous video. That's all I got. Take care. Bye.